for our origin, or for our plane here, one of the main things is that you're going to need to know what the signs are. Not only for us, but when you go to the end of Algebra 2, beginning of pre-cal, if you get to those later, it's real important that you know positive, negative, so on, because it's going to make it a lot easier for you to determine sine and cosine changes, all those kind of weird things that are hard to see. So that's our basic outline that we're going to do. Now the next thing is, right here when we talk about the Cartesian coordinate system, and if you can't read this up here, and it's what's listed at the top of your page. So the Cartesian coordinate system is used to graph relationships between the quantities. So we drive again, we have our number lines, x and y. We've got quadrants, 1, 2, 3, and 4. And we usually have points, or another word for it is ordered pairs, that are written as x and y, or x, f of x. One thing we're going to get really comfortable with looking at, because really it's the technically correct way to write, is this. The way that that's read, it's also listed on your paper smaller, the way that's read is f of x, which means f is a function of x. You may see instead of y equals 2x plus 3, you could see f of x equals 2x plus 3. It doesn't mean anything different, it just simply means that this is taking whatever x is, and it's putting it into a function. It's just another way of writing it as you go along. It's kind of like when we're really young, we talk about whole numbers, and then we start adding in some negatives, and then we start putting fractions and negatives in letters, and it's the same idea.
Why is it jump?
It's because it's recording.
So, like, y is like the first number, then f is a function.
It's not the first number, okay? Relation can be graphed as a point or a set of points. For the set of ordered pairs, we want to know which quadrant these are in. You refer back up to the top. You see we have negative 2 thirds in quadrant 2. 0, 0 is the origin. 2, negative 5 is down here. 0, 3 is the one that we get hung up on sometimes. 0, 3 would be a point on the y-axis. It's on the origin, it's on quadrant 1. Okay, because 0 is not considered positive or negative. It's on the origin, on the axis. So we need to be careful. If this had been 3, 0, this would be on our x-axis. Okay? So we need to be careful that we describe it correctly. So any question about just our basic coordinate graph? I think most of us probably seen all that before. This is where it's going to start new, okay? And I'm going to erase this so that I can describe it a little bit better. Okay. Down here, when we talk about things in algebra, where we're talking about letters and graphs and all this kind of stuff, when we talk about analyzing graphs, last time we did it with data in the calculator. We want to be a little more specific. So right here, what we want to say is that the domain of a relationship is a set of x values. Okay? So we're talking a graph. The first number in your order pair is your domain. Domains can be discrete or continuous. So what's the easy one? What does the word continuous mean? Yeah, it keeps on going. Okay, so continuous keeps on going. Discrete, think about discrete and dots. Okay, discrete is broken lines. So we have two with our domain. We can have discrete which has broken lines, or we can have continuous, which is a solid line. An example of discrete, if you're talking about objects that can't be split up, for example, people, living things, cars. Go about cars in the parking lot. You're not going to say there's 2.5. You say there's 2, or there's 3, or there's 4. That's discrete. Continuous is more like your growth. You don't jump from 4'6" to 5'3" instantly. And you grow between those. So measurement is going to be more of your continuous. Discrete is going to be something that can be split up. Range is going to be your set of your y values. Now, bottom of your page, once you put this, before you flip your page. Now, this is a funny picture here. I'm not a great artist here, but I want you to think about it. Domain is here where you start. And since I use the golf clubs, it's kind of a golf club. Okay? When you hit where you end up over here is your range. If you are a hunter or if you go to a rifle range, same idea. Where you start, where you stand is your domain. Where you are shooting targets or ending up is your range. Yes. So think about range as your result, domain is your starting point. Okay. We got a little short description here. Relations in which each element of the domain, which is x, is exactly one element of the range, which is y. It's called a function. So if we say the set of data is a function, each x is paired with one y. We can look at some examples of what that means in a minute. Also, if it's a function, x cannot repeat. And the graph must pass the vertical line. So if we have a function, everything is a relation. We talked about that before. I can list anything that I want to for x, anything I want to for y. It may make sense, it may not. However, if I have one x with one y, then it's going to create a specific kind of relation that's a function. If I put it on a graph, it has to pass the vertical line test, which means it can only touch one point of that graph at a time. If it's in ordered pairs or a table, none of our x's can repeat. So this would be a function because everyone got off the bus one time. No problem. If I look at over here, well, Jill's okay, she got off once. Gary and Tanya both got off at D, but Bob is a problem. Because if Bob got off at A, he can't get off at B because he's not on the bus anymore. So this is a problem. It cannot be a function because Bob cannot get off twice. Or 3 times or 4 times or whatever. Okay? That's the difference in a relation and a function. Another example of that might be this. little trick here. Think about this. You have x plus 3. If x is 2, what's 2 plus 3? 5. And if x is 4, what's 4 plus 3? 7. I can keep going. Okay, 6 plus 3 is 9. So on. If I come down here again and I say, okay, I'm going to use 2 again, but this time 6 plus 3 is 10. Is that true? No. That's the problem. Up to right here, this is a function. These are my x's, these are my y's. 2, 5, 4, 7, 6, 9, everything's good. When I add this in, which is not a true statement, it's not a function anymore. Because 2 cannot go to 5 and to 10. That does not make sense. That's the difference in a relation. I can list them, but it doesn't make sense. If it makes sense, it's a function. Okay? One other thing on here, to finish up. If we have this on a graph, and x is increasing while y is increasing, is our function increasing or decreasing? Decreasing. These are pretty easy. If y decreases while x increases, what kind of function is it? Decreases. We don't usually have a problem with that. What we're going to want to do is identify, is it a function? Is it increasing or decreasing? And is it discrete or continuous? Those are the 3 things that we want to look at. And we're going to do that down here on why that it's like that.